The following webinar is presented by the E-Extension Farm Energy Community of Practice at extension.org and the University of Nebraska Lincoln Extension.
All right, hello everyone. Welcome to the April edition of the Bioenergy Friday web seminar. We've got a very good topic for us today. Thanks for joining us. We have with us today Dr. Wally Tyner from Purdue University. Welcome, Dr. Tyner.
Okay, thanks, John. What I'm going to try to do is give you a little bit of history, give the definitions that are in the Renewable Fuel Standard, and talk about RINS, how they work, how they're issued, all that sort of thing. I'm going to interject something there on the blend wall because that's become, it's been a topic for 3 or 4 years, but it's become this year even more important because for the first time EPA has recognized that it exists. Then we'll talk more about RIN prices. Then we'll talk about the EPA 2014 proposal for the Renewable Fuel Standard, and finally some conclusions. So let's jump right in with the history. We've been subsidizing ethanol since 1978, the Energy Policy Tax Act of 1978. And the subsidy ranged between 40 and 60 cents a gallon from then until 2011 when it ended. And the biodiesel subsidy ended in 2013, although they're attempting to get it restored. And so far, every time that it's ended, they've been successful at getting it restored. We'll see what happens this time. So in this period between period between 1982 and 2003, crude oil ranged between $10 and $30 a barrel, averaging about $20 a barrel. And at those crude prices and at subsidies around 50 cents a gallon, the subsidy was enough just to slowly grow the ethanol industry, but it didn't put undue pressure on corn prices. And then that all began to change in 2004 when oil prices started up the chart. So you had a subsidy keyed to $20 oil, and oil went from 20 to 40 to 60 to 80 to 100 and on, and you know the story. So for a while, in 2006, for example, you could pay off an ethanol plant in 3 months if you could have instantly built one. It was in 2005, 2010 that the ethanol industry changed substantially. Okay, so in the definition of the Renewable Fuel Standard, it provides for 36 billion gallons, most of it ethanol equivalent by 2022. There are 4 categories: biodiesel, cellulosic advanced, other advanced, and conventional. But the key is that it's a nested structure, and I'll explain more about what that means. But one important thing it means is that only corn ethanol counts for the conventional category, but biodiesel, other advanced, cellulosic can also fill the conventional category where corn ethanol goes. This is a slide that I've used many times. I'm sure you've seen it before. It shows the growth of these different buckets in the Renewable Fuel Standard. The yellow is corn ethanol. It was slated to be 14.4 billion gallons in 2014, and EPA has proposed reducing that to 13 billion gallons, mainly because of the blend wall. And then the total, adding up all these categories for 2014, was 18.15 billion gallons, and EPA has proposed reducing that to 15.21. We'll come back to that later. The blue is cellulosic biofuel, the green is other advanced, and the red is biodiesel. This is the nesting structure. So you see down at the bottom, there's this conventional category that reaches, in principle, next year 15 billion gallons. And it is the only category that corn ethanol can go in. Then there's, on the upper left, there's the biodiesel category that was 1 billion gallons. EPA has increased that to 1.28, and only biodiesel can go in that category. In the upper right, there's cellulosic, 16 billion gallons ethanol equivalent, and only cellulosic biofuel can go in that category. But cellulosic and biodiesel can also go in the other advanced category, as can sugarcane ethanol, all of which is imported. And cellulosic and biodiesel can also go in the conventional category. So in principle, were it not for economics, you could have a renewable fuel standard that had zero corn ethanol, because it could all be cellulosic and biodiesel filling the conventional category. That's not likely to happen because corn ethanol is cheaper than either of those other sources, but that's the way the RFS is set up. Congress wanted a limit on how much corn ethanol could be used. It wanted to move towards cellulosic and other advanced biofuels. It wanted a role for biodiesel. You can see all kinds of compromise and negotiation in the setup of this, but in fact that is exactly where we ended up. I've got a question here that says, how is it determined which category cellulosic goes in? Well, it goes in the cellulosic category if it's needed there. If it's not needed there, it could spill over into other advanced and conventional. Okay. So what are the definitions? And I'll run through this fairly quickly. The biodiesel category, which goes by the code D4, it's 1 billion gallons in the law, but EPA has increased it to 1.28 billion. It has to reduce greenhouse gas emissions by at least 50%. It can be, and this is key, it can be transportation fuel, it can be a transportation fuel additive, it can be jet fuel, heating oil, it can be the ester-based biodiesel that we're familiar with, which is soybean oil or McDonald's grease or whatever, that is converted to biodiesel with a transesterification process, or it can be non-ester renewable diesel from cellulosic or also with a process called HEFA from oils. And biodiesel, it is required, as I said earlier, for the biodiesel part of the renewable fuel standard, but it can also fill those others. Cellulosic is biofuels from corn stover, miscanthus, switchgrass, forest, any of these and municipal solid waste, any of these cellulosic feedstocks. It must reduce greenhouse gases 60%. And every year that there's been a cellulosic mandate, it has been waived, and it will continue to be waived throughout the rest of the life of the renewable fuel standard, because I don't care what happens in technology growth, it can't grow from this point forward as fast as the RFS grows. And the importance of that is that there is a clause in the renewable fuel standard that any time EPA waives 1 gallon, any part of the cellulosic advanced category, blenders have a right to buy out of their blending obligation. They can buy a credit from EPA, and the price of that credit or the way it's priced is fixed in the law. So they buy a credit from EPA. If I remember correctly, the cost of the credit this year was 43 cents. And they can buy an advanced RIN, and advanced RINs now are about 52 cents. So for less than $1 a gallon this year, a blender can buy out of the cellulosic advanced obligation. And since the cost of producing any cellulosic biofuel is more than $1 a gallon, higher than fossil fuel cost, that's what they would likely choose to do. So the RFS mandate all of a sudden is no longer a mandate. It has an off-ramp that you can get off of really easily. So that last provision is an important provision for that category. The other advanced category, it's a wide range of things. Sugarcane qualifies, sugarcane ethanol qualifies, biodiesel, cellulosics. An EPA even approved recently sorghum ethanol under certain conditions as meeting that 50% greenhouse gas reduction standard. Conventional biofuels, that's the only one that corn ethanol can fit into. It has the code D6. It requires a greenhouse gas reduction of 20% at least, but any ethanol plants that were in operation or under construction as of the passage of the Energy Independence and Security Act in December 2007, those are all grandfathered, and that's most of the production. So technically, corn ethanol doesn't have to meet most of it doesn't have to meet any greenhouse gas reduction standard. For 2013, the RFS level was 13.8 billion gallons. In 2014, as I said earlier, it was slated to be 14.4, but EPA has proposed reducing it to 13 billion gallons because of the blend wall. We'll get back to that. Okay, how does this, so the way the Renewable Fuel Standard is enforced is through RINS, Renewable Fuel Identification Numbers. So how does that work? Well, this chart shows how it works. Let me see if I can, I don't know what happened to the arrow. There it is. Okay, so RINs are generated at an ethanol plant. Every time you produce a gallon of ethanol, you produce a RIN, and blending obligations are incurred anytime you import gasoline or diesel, or anytime you produce in a refinery gasoline or diesel. And so the obligated parties are the refineries that produce for the domestic market and the importers of fuel. And so EPA each November estimates what the share of the total market is going to be for each obligated party and assigns them a blending obligation for the next year. Then the ethanol plants produce their ethanol, produce the RINs, and then once the RINs once the ethanol is sold, whoever has them can separate them. The fuel then moves on to the service station. The red lines are the fuel, and the separated RINs come down and are used to meet the blending obligations, which are the blue lines, or they can be traded. Now, one important thing to understand is somewhere between 15 and 25% of the RINs are traded. Most of them are just used to meet the obligation that a party has. So that's sort of an overview of. Okay, here's a question. Well, let me answer. There's a greenhouse gas question first. Will greenhouse gas required calculated using total life cycle analysis figures? EPA calculates the reductions, and they use a 30-year cycle in doing that, and they include in their calculation induced land use changes from the biofuels. They include, Congress required them to do that. They include the whole life cycle over an assumed 30-year life. Then there's a question, why is it that refiners suggest the RIN is a cost to them? It's a cost to them if they don't have enough to meet their obligation. In other words, let's say that you're a big oil company and that EPA has estimated that what you produce for the domestic market in your refinery plus what you import is 10% of the gasoline market for next year, or for this year. Since we consume 133 billion gallons of gasoline in the United States today, a year, your blending obligation is going to be 13.3 billion gallons of ethanol. So you're going to have to buy 13.3 billion gallons of ethanol and the attached RINs in order to meet that obligation. If for some reason you don't do that and you have to buy the RINs to turn in at the end of the year, then that's a cost to you, and that's what they're talking about. Although they would consider the whole thing a cost, but the only dollar cost they incur is for any RINs that they have to buy. Okay.
There's also a beet sugar question. I don't want to miss that one. That one says, will beet ethanol qualify as an advanced biofuel?
It should, if it's processed using, I haven't seen if EPA has done a pathway on that, but I would presume that it would get a scoring pretty similar to sugarcane ethanol, but I haven't seen that. It's a good question, but I haven't seen an answer. Okay, I think I've gone through most of what's on this slide. Obligated parties are refiners for the domestic market and importers. One of the largest refiner in the country is Valero, and they are also in the ethanol business. They decided that the easiest way for them to get the ethanol that they need to meet their obligation is to produce it. So they recently acquired a new ethanol plant, or another ethanol plant here in Indiana. And the rest of this just explains what I said before about how the blending obligation is calculated. One of the things to note, though, is that I said that today we're consuming 133 billion gallons of gasoline a year. In 2007, when the Renewable Fuel Standard law was passed, we were consuming 141 billion gallons of gasoline. So we're consuming today 8 billion gallons of gasoline a year less than we were in 2007. Part of that is the recession. Part of it is fuel economy standards. Our fuel economy standards are in the process of doubling from 27.5 miles per gallon up to 54 miles per gallon in 2025. So it's a combination of the economy and the higher standards that mean that our total gasoline consumption is less now and it was expected to continue to grow in 2007. So that's one of the things that's changed. So in addition to the other definitions and rules that I've talked about, there's also what are called carry forward rules. There also are borrowing rules. You can borrow, I probably won't get into that today, but you can roll RINs forward from one year to the next. The maximum amount of carry forward RINs that you can use is 20% of that year's blending obligation. Nick Paulson from Illinois has done a good job, I think, of estimating periodically what the RINs, the amount of RINs, carry forward RINs might be available at different points in time. Going into 2013, I think he estimated it was about 2 billion gallons. Going into 14, it's over 1 billion gallons, and how much over depends on where EPA ends up with the Renewable Fuel Standard. But the point is that there is still a sizable cushion of RINs left over from 2013 that can be applied in 2014. Now, this is the blend wall that I was talking about before. At 133 billion gallons, and using only the 10% blend of ethanol, the max we can consume is 13.3 billion gallons if every drop of gasoline were blended. You'll say, well, we have E15 and we have E85, and that's true. E15 is absolutely tiny. It's not even fit on the chart. E85 is a little bit larger, but it isn't growing, so right now, almost all of the ethanol we're consuming is as E10, and there's a limit on E10. So, and we've been at this limit for some time, and when you're at the blend wall, ethanol gets price break even with corn for the marginal producer that just meets the wall limit instead of being tied to gasoline price or crude oil price. And then when the market perceives that the blend wall is binding, that's when RIN prices go up, and we're going to see that in just a minute. But with higher RIN prices, it could become more attractive to market more of the E85, and we'll come back to that in a second as well. Okay, this is a history of RIN prices, and this is just the D6, if I can get this. Okay, let's start down here at the beginning, end of 12, beginning of 13. If you were to take this graph way to the left and go back to the rest of 12 and 11 and 10, it would have shown you that the price of corn ethanol RINs were generally around 3 cents a gallon. The renewable fuel standard wasn't binding. The market had moved faster than the renewable fuel standard. So the first indication that the market saw that there was a problem was in March of 13, when this 3 to 5 cent price went up over $1 a gallon. Now the other RINs had been higher, biodiesel RINs and advanced biodiesel, advanced biofuel, cellulosic, and those had been higher. But what happened was that when the market finally saw, I kept saying for a long time before this that the blend wall was about to be a really big deal, and the market didn't believe me clearly. But all of a sudden, in just a matter of a couple of weeks, they decided, yeah, that's right. And so the price of RINs shot up. And it stayed, these are corn ethanol RINs, again, D6. They stayed high until August of 13, when EPA announced in EPA's final ruling for 2013, where they set the final numbers for 2013, they also said when we go about establishing the 2014 mandate, we're going to consider some things that we haven't included in our calculation before. We're going to consider how much the overall mandate needs to be. Prior to 2014, they had reduced cellulosic mandate every year, but they hadn't reduced the overall mandate. So even though they reduced cellulosic because it didn't exist, and you can't require by law people to blend something that doesn't exist, they didn't reduce the overall. So that gave an opening for more biodiesel, more sugarcane, etc. But in August of 2014, in their 2013 final ruling, they said, we're going to consider two things. One, we're going to consider this overall mandate. What should it be? And second, we're going to consider the blend wall. Well, then, of course, the market said, okay, the blend wall is no longer the issue that we thought it was. And the price of RINs fell at one point below 20 cents a gallon for corn ethanol, because the market was perceiving that it really wasn't an issue. Since then, they've been going back up. They're currently 42 cents a gallon for corn ethanol D6 RINs. Biodiesel RINs are currently 57 cents a gallon, and advanced are 52 cents a gallon. So they're all running together. Now, why would today they be running together when all throughout history the other categories were way up here and corn ethanol was way down here? Well, there never had been an issue with meeting the corn ethanol RFS. You knew you could meet it, and you knew you could meet it with corn ethanol. But now they're starting back here. Oh, well, maybe we can't meet this. And so what happens is a corn ethanol RIN becomes almost as valuable as an advanced biofuel RIN or a biodiesel RIN because why? Because biodiesel can be used to meet the corn mandate and advanced can be used to meet the corn mandate. So these prices rose essentially up to where the advanced were. Since then, with the reduced pressure from EPA, all of them have fallen. And so they're all in the 42 to 57 cent range now. And we'll have to wait and see what happens with the final version of the EPA 2014 mandate. The RIN prices are set by supply and demand. Like I said before, it's only about 20% of the total market. 80% is just used to meet the obligation of the people who do the blending. So it's a fairly thin market. But the RIN prices, like prices of many commodities, are priced sort of. A big factor is what you can think of as stocks to use ratio. What's this carry forward stock that I talked about? Paulson's estimate, it's 1 billion gallons this year. And what's the anticipated need? And so it's somewhat akin to stocks to use in corn or soybeans or anything else. Big factor in determining what the price of RINs is going to be. Now, there are a lot of differences too, but that's certainly part of it. Okay, let's move to E85. Bruce Babcock at Iowa State has done what I think is some very nice work and has argued that there's a lot of potential to expand E85. In fact, his paper estimates that 800 million gallons could be absorbed with existing infrastructure, meaning no more pumps, no more flex fuel cars, just what we have today, if RIN prices were high enough. Because if RIN prices are high enough, E85, it says 85, but it's actually about, on a year average, about 75% ethanol. That's a lot of RINs. When 7.5 gallons out of 10 is ethanol, you sell 10 gallons of that, that's a lot of RINs. And so if the RIN price is high enough, his argument is that you could expand that market with no infrastructure increase, 800 million gallons, and if you invested in more pumps, and particularly pumps in the Midwest, where the ethanol is, the pumps need to be where the cars are, and so the cars are all over the place, Midwest, East Coast, West Coast. And so right now we have about 15 million flex fuel cars. My estimate is that those 15 million flex fuel cars we're using only about 3% of the capacity of those cars. If you look at the E85 sales and what you would expect E85 sales to be if they were using E85 year-round, driving about 12,000 miles a year, which is the national average, we're using only about 3% of the capacity of the E85 vehicles that we have. Until recently, ethanol was about 75 cents a gallon less expensive than gasoline. So you couple that with RINs that are much higher in price, and you could stimulate the demand for E85. So I think Bruce has got a good point. Recently, though, the price of ethanol has been much higher, partly because of the winter and partly because the cars are being used to ship Bakken shale oil. There's a real shortage of cars for ethanol. And so the ethanol price has increased. Okay, so this is let me see, there's another. Okay, not really a question, just a comment. Okay, this is the current RFS on the law in the books. So it totals 18.15 billion gallons. This is EPA's proposal, and that's 15.21 billion gallons. So EPA has proposed, as you can see, they dropped the cellulosic drastically. They think there's going to be, in 2014, 17 million gallons of cellulosic available. So that's where they set the cellulosic. They're continuing proposing to continue the 1.28 billion in biodiesel, which is what it was last year. They reduced the advanced and the other advanced and corn ethanol. And that was this proposal. Most of this proposal wasn't controversial. The controversial part was here. We actually consumed a little bit more than that, 13 billion gallons of ethanol in 2013, but their estimate was that that's all we can consume because of the blend wall, and so that's where they set the RFS in their proposal. The industry has railed against this, saying that that's not a good representation of what the potential is. The industry has said when Congress puts on a mandate, they do so because they recognize that the market won't get the solution that we as society desire, so they put a mandate on knowing that it's likely to be more expensive than a market solution would be. Otherwise, you wouldn't need a mandate. So there's been a lot of resistance to that one change of reducing effectively the corn ethanol mandate from 14.4 to 13.01. And most of the controversy before the comment period ended was on that point. There was very little on these other points. So this total reduction is a reduction in the 2014 RFS by 2.94 billion gallons. So it's the first time that EPA has reduced the overall, and they reduced it big time. So that's where a lot of the controversy is. The column labeled new option is just an option that I put out that I thought if Bruce is right and I get similar results in my calculations, we could easily meet something around 13.8, 13.9 with more E85, and so it seems to me that it makes sense to have something higher than a number that's lower than what we actually produced or consumed last year. And I have some differences, smaller differences with EPA on the other side, the other points. And so my proposal for 2014 was 1.2 billion gallons higher than theirs. The other point I would make on the corn ethanol is suppose Bruce and I are both wrong, and that could be. We have 1 billion gallons of carry forward RINs. And so we just use those and then recalculate, reconfigure in 2015. My sense is that EPA is not giving the system, the RIN system, if allowed to work, would see RIN prices increasing and would, I think Bruce is right, would stimulate more expansion of E85. But it will not happen with this proposal, with the 13.01 billion gallon proposal. So let me conclude, and then I'll come to questions. I see there are a couple of new ones. The RFS is pretty important for the biofuel sector. It's now come under attack. A lot of different quarters. The oil industry, big time. Livestock groups in some cases, grocers. So it's come under attack like never before. What are the consequences if we eliminate the RFS? It would kill renewable fuel growth. Cellulosic biofuels would be dead. Biodiesel would go under. Interestingly, though, I think ethanol would pretty much hold its ground, particularly in the short run. The whole refining and distribution system in the United States was changed in 2008, 2009. The oil industry decided ethanol was here to stay. They reconfigured many of the refineries from producing 87 octane gasoline out of the refinery to 84 octane gasoline. If you blend 84, which is cheaper to produce, if you blend 84 octane gasoline with 10% ethanol, 10% ethanol has 115, or ethanol has 115 octane. Do the math and you see that produces an 87 octane fuel. So the oil industry was and is saving money by producing a lower octane fuel to blend with the high octane ethanol. My contacts in the industry, both the ethanol industry and the oil industry, suggest that near term that would continue. The market for ethanol would continue. So if the RFS were to go away, the other cellulosic biodiesel would go. Ethanol would likely stay at least near term. The alternatives to ethanol, alkylates, right now are more expensive, considerably more expensive than ethanol. So it would continue to be in the economic interest of refiners to blend the ethanol, even if they weren't required to.
This webinar has been brought to you by the Farm Energy Community of Practice and the University of Nebraska-Lincoln Extension. For more information, go to farmenergymedia.extension.org.